Welcome to the seminar. The Institute of Aquatic Ecology. The Institute is a group of different research groups, and here today we have Jordi Boada. Okay, and he is a close collaborator of our marine research group, and he studies the benthic marine ecosystems and how it can be affected by several stressors. He's a Marie Curie fellowship now in University of Sorbonne, and he is going to explain a little bit what is the project that is in here. Okay. Thank you very much.
Thank you, gràcies. Això jo crec que és com jugar a casa, Fa molta il·lusió estar aquí. I ara em posa més potser aquest format que no el... Però bueno, okay. I'll shift to English because maybe there's someone from abroad listening. If you want to stop me for questions, maybe we can do it in a more relaxed way, or if not, I will answer questions at the end of the presentation. So, well, thanks for having me here. I've entitled my presentation today as it reads here, Shifting Perspectives from Marine Macrophyte Collapses to Global Environmental Change, Mitigation Agents. And I did this basically because of two reasons. The first one is because it's the title of my current project, postdoctoral project in France, but also because it sort of reflects the pathway of my research from studying the collapse of marine ecosystems and trying to find actions that help us prevent ecosystem collapses. No? So I'll try to reflect this on my presentation today. This is the Laboratoire de Villefranche, where I'm based currently. These squares down here at the offices, one of those is my current office. And this is an old military building. And these were actually the prisons, the cells of the prisoners. So I'm really working in an old prison cell. And the Laboratoire is a mixed institute between the CNRS in France and Sorbonne Université, where I'm doing my postdoc now. It's a really beautiful area. It's a very Mediterranean sort of landscape in the French Riviera. It's a small bay that resembles very much to places in the Balearic Islands, and it's quite impacted, I would say. So imagine this small bay, very typical, as I said, from a Mediterranean landscape, with these huge cruisers coming almost every day in summer, anchoring inside the bay. Sometimes there's two of them. There's a lot of population living in the coastline. And as a result of this very populated area and the human actions in the coast, the coastal systems are quite impacted for several reasons. We have lots of invasive species. Here you have the Cajal, which came originally from Monaco, very close to this place. It's present in the bay. There's also lots of nutrient loads in the area, and yeah, as you imagine, pollution, many other impacts. No? But to start my presentation, I did a mix of more technical and then more applied presentation. Today I wanted to bring this diagram up front because it reflects one of my main interests in research, and is how ecosystems can change from a healthy state to a very degraded state following what is called tipping, critical transitions with the presence of tipping points, after which the ecosystem completely collapses, and it's pretty difficult to revert the situation to the original state. This is an example of a lake, Hamilton Lake, from France, from the Limno-Pirineos project. It's very difficult to revert the situation because of the presence of these deficits, and that's related to many ecological processes that act in these ecosystems, and basically in complex systems. And basically, that situation is very different from other types of transitions in ecosystems, and carries important implications for, as I said, the conservation and the recovery, compared to the sort of linear transitions that when we remove the stressor, the impact, the ecosystem can recover following more or less the same path that on its way forward. Conversi and other authors describe it very well, and this scheme reflects quite why these systems, these complex systems are interesting. This moves a little bit beyond the classical top-down and bottom-up control. No? We have physical and biological stressors that basically affect the endogenous dynamic of a system, and that eventually enables the creation of regime shifts, important regime shifts, sometimes in large scale and temporal expansion. I will show you now a couple of examples I had the opportunity to collaborate with. This one you see here is the crown of thorns starfish. It's a coral eater. It's very voracious. And what you see in this graph is the preference index, or the electivity index between the different types of coral that are in a coral reef community. And this starfish has a lot of preference, like a huge preference for acropora corals. And its behavior is like, if there is a corpora present, it will stay foraging in a very controlled range. If there's not, then it will move. This is what this graph reflects, to other areas finding this resource. When these populations outbreak because overfishing caused the collapse of the predators, then the landscape turns out like a bleached coral reef, which is very difficult to repair because we know that afterwards there's algae growing on top of the structure of corals and so on. So this state shift can have important consequences. Another example is in the east coast of Australia. This is Caulerpa filiformis. It's a native species there, but it has sort of alien or invader behavior. Yeah, it grows very fast, it retains sediment, so it makes it very stable when it comes. And due to temperature increase, water temperature increase, this species is moving upwards. Then the situation is that this will be the sort of typical community, macroalgal community in these coastal systems, but the preference of the native herbivores, in this case sea urchins, for the interest in relation to the ecosystem services that offers for kelp species, sargassum species that enable this complex, diverse system to exist, then favors the expansion of this seaweed. Then there's many areas in the east coast of Australia at the moment that are being transformed from this diverse and productive ecosystem to this simple, homogenized, and basically of a single species ecosystem that is less productive. In the marine realm, actually, in vegetated systems, transitional linear transitions exist for plenty of ecosystem. I would bet that for most of them. One of the things I studied is the transition between macroalgal forest and sea urchin balance. I will come to this example later, but here you see how we identify the critical number of sea urchins that can cause the collapse of the full macroalgal community. Shaping the ecosystem from a forest, marine forest, to a desert underwater. For the emblematic Posidonia oceanica, we have similar cases, and this is a very interesting study from Ruiz-Lines in 2017, describing the different stable states of Posidonia before collapsing to a bare sand. And finally, to show you another example, this is Thymodothea nodosa, another seagull species. The deep limit of distribution of Thymodothea, in this case the Delta, we find it like very well described by this critical transitions concept. So what you see here is the shoot density of the seagrass meadow according to the depth, which reflects in fact the gradient of light limitation, and below 2 meters depth, the shoot density basically collapses to zero, and you have a bare sand ecosystem. But my topic of interest or topic of study, it's mostly focused on this habitat simplification here that I try to illustrate with this slide. From marine forests to miniaturized turf communities that are very stable, or to bedrock, which is the extreme low productive state of the ecosystem. And for the two types of transition, it has been described that this concept of alternative stable state is plausible, and particularly here in the Mediterranean, we saw that this is also the case. When these collapses occur, there's several processes that help maintain this new ecosystem state in its degraded state. For instance, for turfs, turfs are basically composed of fast-growing species, colonizing species that cover virtually all the available area, and that first retains more sediment, and that goes against the settlement of any other algae of interest. So as a result of that, we have lots of landscapes here in the Costa Brava, for instance, which are dominated by these turf communities. In barrens happens something very, very similar. Barrens in Catalonia, for instance, in the Mediterranean in general, are related to the presence of sea urchins because of, again, the lack of their predators. The more urchins we have, the more the more the recruitment is enhanced of sea urchins, and then the more herbivory pressure in the area. So that acts again as a reinforcing feedback of this degraded state. The less macroalgae, the less kelp available in barrens, in the neighboring areas of the barrens, the more difficult it is that the system can recover to its original healthy and diverse state. So all these feedbacks act again, making these conditions very, very stable. And what we have here in the Mediterranean, what's the topic of my study mostly, is not a separate example. It's not only. It's basically something that happens all across the temperate areas. With this, I wanted to illustrate that all the canopy formings are getting reduced or get simplified to these turf-dominated ecosystems. So what you see here is different seaweeds we studied in the specific work in collaboration with international researchers led by Alberto Sandora, showing that when we lose the canopy forming species of interest, we are getting everywhere the same sort of homogenized, miniaturized habitats of turf species. And that is in relation, you see, to many different impacts, including warming, storms, like pollution, herbivory, and so on. But to bring an example of the Mediterranean, I will come to this sea urchin study that has been central for many years of my research. Things are complex in sense of sometimes there's physical stressors, sometimes there's biological stressors, basically creating these phase shifts, but sometimes it's the interaction of both that makes some place more vulnerable than others. This is the electromagnetic production of the Mediterranean from satellite image analysis. And basically it's a proxy of the nutrient content of the Mediterranean, with these reds, orange and yellow areas being the places in the Mediterranean in which the water has more nutrient content than for example, islands in the eastern Mediterranean, which is very, very eutrophic. We did a study in which we explored which were the limits for the macroalgal population. You know that the nutrient content is very important for algal growth, but also for consumption. So in this graph you see the combination of sea urchin biomasses with macroalgal cover. Each dot represents a quadrant, so we throw lots and lots and lots of quadrants of 50 to understand which was the actual relation between sea urchins and biomass, and to find which was the vulnerability index of each macroalgal community. No? This is what we found in the places with more nutrient-rich waters in the Mediterranean. They can sustain up to 2,000 grams per square meter of sea urchins. But the interesting is that in low nutrient conditions, this threshold, so this critical threshold that the dashed red line shows, gets reduced to the half of the sea urchin biomes. And that is in response of the nutrient availability of the system that favors, so the more nutrients the algae can grow more, and urchins need less algae to feed the metabolic requirements. This is how this systems look like in the different places, and it's obvious that in one place you need lots and lots of urchins to create a collapse, while in the other you have barrens with just a few sea urchins. But coming to the sort of loops, sort of feedbacks that make these barrens very stable once they are created, what we have here is the relationship between the barren cover and the arrival of limpets, which are a second herbivore, a mesograzer, which importance seems reduced, but actually it's specifically in oligotrophic waters is very important, as you can see now. In this photo, we have a limpet and we have the grazing mark around. So the grazing mark basically is reflecting the balance between growth of the algae and consumption by the herbivore. And these marks were way higher in low oligotrophic conditions. So again, similar to what we found for sea urchin. This is the same, but according to Scheller, so that the size of the limpet, the greater the limpet, the greater the impact it has on the algal community. So what this eventually transforms to is that in some places in the Mediterranean we have oligotrophic waters, even if there's no urchins, once the barren is created, these limpets can arrive and actually make the system very, very stable for a long time, only because of this small effect of limpets. This is an observation, I will come to this project later on, but basically shows a place in which there's no sea urchins in a very oligotrophic area, and there's plenty of limpets that potentially maintain this barren state stable for a long time. So just to show you an example of how feedbacks act. This is related to the collapse part of it, and at this point I wanted to bring back the shifting perspective title, because this reflects, again, is a personal shifting perspective. So I'm trying to look now more on how we can use this information based on the ecosystem to avoid crossing tipping points, to avoid crossing critical thresholds. And I'll show you a couple of three actions that we are currently taking in order to provide or go against these collapses. No? The first one is this one. We're working closely with the administration. We work with the fisheries department in order to find places along the Catalan coast to identify the differential vulnerability of the macroalgal community. This is a summary of the sort of graphs that I presented before with the relationship between sea urchins and macroalgae. So what we see here is that this is the sea urchin density. When we reach 6 sea urchins, we're losing the half of the macroalgal community cover. That's very important to know, because that can, given that we don't have fish that control the sea urchin population because of overfishing, it's very important that we find ways to keep these herbivores under control. And fisheries are one of the options that here and in many other places we are trying to explore. We are working with fishermen, with fishers, at the same time, in order to provide examples of what happens if we remove all the sea urchins from place. So ideally, that will mean that if we are able to identify critical areas with lots of barrens in them, we can say, look, it's important to concentrate fishing effort in this area, and now we want to assess what happens if we remove all the sea urchins. Now this is a sort of pilot study that we did in Blanes. This was the original sort of seascape that we had. This is actually 2 months after removing the sea urchins, so there's already a bit of vegetation there. But what's interesting is that in some cases, the sole effect of removing the sea urchins can provide a good substrate for this macroalgal community to pay back. This is anecdotically, but actually in one of the places that in which we did this sea urchin removal, we had CEAB-CSIC canopy-forming species coming back that were ready to a very specific place in Laboratoire. We started seeing these individuals there in a place that was originally a barren. Things are not that simple. Then we had grazing after this and so on, but at least it's a proof that, you know, with appropriate management, we can contribute to the conservation of the coastal communities. The second sort of action we are doing is the Hidden Desert project. We started a citizen science project to detect where these barrens are. We are limited as a researchers to specific areas on the coast that we know because we traditionally studied them or whatever. But we need lots of people to inform where these barrens, these marine deserts are, in order to provide solutions to this problem. This is a small video we need to present the project. That explains very well why macroalgal communities are disappearing.
Forests. Their living structures are home to a long-lived life. Like terrestrial forests, underwater forests are under threat. Climate change, pollution, and overfishing are causing them to disappear. With them go their associated fauna, including the fish. Is bare rock. Hidden beneath the surface, these deserts are a sign of an ocean in serious trouble. Now it's time to uncover them.
And the Hidden Deserts Network is basically a group of international researchers working on this topic, on the collapse of marine macrophytes due to several reasons: pollution, climate change, overfishing. And so far we have identified, with the help of Observadores del Mar and all the people that is behind the project, around 150 deserts across the globe. Lots of them in the Mediterranean, because that's where we have more presence. But we are working on it every day to increase the number of barrels that we have identified across the planet, to try to use this information to propose the appropriate techniques to restore the original system in a long-lasting, way. So it's not that we restore it and it's lost after 1 year. Related to this project, we also do try to do a strong communication action, because we found out that the desertification of marine forests was a very unknown event, a phenomenon. I wanted to show you this photo because for me it's a success. She's Zia, a friend of mine. She's a content creator and with a lot of influence in social media. And she used to transmit the problem of plastic pollution in the ocean and so on, but she wasn't aware about the existence of either marine forests and marine deserts. And all of a sudden, one day, after working with her, she came up with this photo. I wasn't there that day. So I realized that she, got the problem, was helping us to communicate to the broader public, because what we have here is a typical Mediterranean marine forest. I wasn't there that day to say, look, this is the forest. So she, was able to identify it by herself and identify barrens as well. And she helped us a lot in communicating this problem. And finally, and we go back to the science, sort of the more basic science, which relates to my current Marie Curie project in France. We are trying to evaluate how marine macrophytes will be able to adapt to future climate conditions, both of warming and ocean acidification. This study got a lot of attention a couple of weeks ago, discussing the effects of crossing the 1.5 global warming for the different tipping elements of the climate system, of the planetary Earth system. At a different scale, we've seen that macrophytes, marine macrophytes, are a tipping element of this system, of the Earth system. So currently in this project, where we are using these natural gradients of temperature but also ocean acidification, this is a seagrass meadow in Ischia. These bubbles are CO2 bubbles. This is a natural CO2 vent. Basically because there's volcanic activity under the surface. No? And the pH here is that of the projected in a century, at the end of the century. So we use those plants to see how they will perform under future temperature and pH condition. And I will show you very preliminary results of one of my first studies within this project. What we did is to simulate the temperature increase of spring for these species in the place that they were collected in Ischia, and simulate the future climate regimes, +2 degrees and +4 degrees. That's what we got inside the mesocosm experiments in temperature records. So basically we placed plants, fragments of Posidonia from off the vents, so that are in ambient pH conditions, and plants from vents at different pH conditions, ambient and low. So those of the vents in ambient conditions were placed in ambient pH and in low pH, and then those from vents were placed in low pH. And then all of them, so at a second level, we had 3 different temperature increases. Those, no? The natural sort of current temperature increase, last year natural, we simulated last year natural temperature increase, and +2 and +4 as I was saying. Basically what we did is taking a lot of information for these plants, we exposed them. So first of all, we went to collect it in Ischia, we took samples for genetic analysis, then we measured all the plants, we put them in aquariums, and along the 2 months that the experiment lasted, we did several measurements for the photosynthetic activity, then for respiration and net photosynthesis, and to measure growth, which is what I will show you in a moment. This is the leaf elongation rate. So what we measured was how fast the leaves of Posidonia were growing, and what we found is that they were very similar in this is the first month of the experiment. Okay? But the blues, which are the plants from the vents, which we could we need to do the genetic analysis, but we can assume that they are the ones that are adapted to low pH conditions, reflect a slightly higher leaf elongation rates. When we look at the panel B, this is the new leaf area. So the total new leaf that each fragment, the total fragment of Posidonia, that was like 20 centimeter fragment with several shoots in it, we see that the production was higher in the blues and greens, which are the ones at low pH conditions. So the more CO2 in the environment probably facilitates the growth, the performance of these these primary producers. And you'll say, okay, yeah, but the differences are very, like, if there's differences, like statistical differences, they are very, very small. Well, this is a photo. I'm not sure if you can see it or not. To show how we measure this, we punch the leaves, each of the leaves from the bases, and here is the mark of the punching. So the holes are moving outwards with the leaf as it grows, no? And that's why we measure the total growth. Anyway, you'll say these differences are very small. That cannot change the performance of the whole habitat, no? Or how this translates to really an increase in resilience. I will show you another example. This is from Mario Minguito. It's not related to future scenarios in this case, but to light, but it reflects very well the importance that a tiny increase in productivity can have for seagrasses to understand the resilience. No? Here we have two growth curves for this seagrass. See the small growth curve and the large growth curve, and then we have a mortality rate. This is sort of a conceptual diagram. Okay. So see, this is small difference in the growth. It's actually extremely important to understand the resilience. And here you have the sort of graphic that I showed at the beginning, the tipping point with the stability case. So this very simple change in growth, like very, very tiny change in growth, is very important to significantly change the resilience of these plants. So we still have to explore a little bit more the data that we got from this experiment, of course, but it's probable that despite the differences are very tiny, the impact on the resilience of the full habitat can be quite strong. And why we are interested in that? Actually, in this paper, a friend of mine did very 2021, they showed how seagrasses are able to buffer the pH changes due to human activities. No? Actually, they found that within seagrass meadow, the pH was higher compared to those in bedrock, and a decrease in pH, which is expected in the future, will be sort of ameliorated within the meadow. And that is very, very relevant for lots of organisms that are calcifying mostly, but inhabit these habitats. No? So, managing these ecosystems in order to conserve seagrass meadows and potentially, of course, marine forest made of other foundation species is critical as well for diversity, for biodiversity. Just anecdotically, inside our experiments with the Posidonia, this is our experiment with the Posidonia 24, we had each fragment within one of those aquariums. The solid lines here reflect the pH condition that was arriving, the pH of the water that was arriving to the lab. Here you have the ambient pH around 8.3, and then here 7.4, the low pH that we had inside the aquariums. But this is actually the pH measured inside each aquarium. This is just a moment during the day. So it's not that it integrates what happens during the whole day cycle, but all of them were above. So plant photosynthesis was actually removing CO2 and actually potentiating this pH amelioration within our aquarium. And I'm finishing my talk to say the idea of this is to use this basic knowledge that we've gathered during the past in order to provide sufficient information to either avoid crossing those tipping points and maintain the ecosystems in a healthy state, or use the information to allow or help, give a hand to the ecosystems to potentiate the recovery of the lost habitats. So yeah, that was what I wanted to talk today. Thank you. And of course, if you have questions, I'm more than happy to answer.
Thank you, Jordi, for your talk.
That's nice.
Was it too fast?
Ah, ho fet en català. Ah, que bé, perfecte. Estava pensant en anglès. Simultània. No diu pot fer en català, dic, perfecte. Bueno, hi ha dues coses per curiositat. Una, l'efecte dels eriçons sobre dels macròfits és igual a l'herbàcia que el paracentrótul?
Això ho estem mirant ara. Sembla que l'herbàcia té un impacte més gran, malgrat és més generalista en el que menja. El paracentrótul és ambigua, estricte, diguéssim, és bastant específic el que cria, no? I en canvi l'herbàcia s'ha vist en alguns estudis que pot menjar també, és a dir, és més omnívor, diguéssim. Però l'impacte que té sobre la comunitat, quan mirem, per exemple, com dèiem amb les lapes, la marca de consum que deixen, és inclús a vegades superior que la del paracentrótul. O sigui que a nivell d'impacte sí, a nivell de què s'alimenta segurament és més generalista, però també això no va en detriment de dir, mira, que pot menjar altres ítems, la marca que fa sobre les algues és més petita, no? L'impacte és el mateix o més gran.
Perquè normalment quan els veus, als deserts, no? Si són olieres i tal, sempre és acàcia. Clar, suposo, bueno, sempre no, ara no ho dic.
Sí, no.
Quan m'hi he fixat, quan m'he dit, m'ha semblat que era acàcia, tampoc ho he anat a mirar, Però esclar, també és el que hi ha perquè l'altre és el que recollim, no?
Clar.
L'acàcia no ens el mengem,
Exacte.
i el paracentrótul sí, vull dir que...
Aquí es junten moltes coses. Primera, això, que a molts dels llocs en els que anem habitualment pot ser que hi hagi pesca de menisquets de grotes. Aleshores, en aquest cas, el que veiem és que hi ha molta herbàcia i paracentrótuls, però no podem dir si és perquè l'han pescat o perquè no hi és. Hem estudiat una miqueta les dinàmiques entre les dues espècies i fan una cosa, diguéssim, com d'anar fent tisores, no? Aleshores, quan hi ha de cop una puja, l'altra baixa, de cop es troben en densitats intermitges, que diries més o menys les dues estan igual de bé. Hi ha diversos processos, un és la facilitació, però sembla que l'herbàcia necessita paracentrótuls per reclutar millor, perquè el paracentrótus faria, l'adult de paracentrótus faria com de protector dels juvenils, però després hi ha, evidentment, certa competència pel recurs, no? Aleshores, les dinàmiques, o sigui, queda encara entendre bé que és degut. Després es comenta que hi ha un augment de l'herbàcia degut a que semblaria que és més termofílic, i per tant l'herbàcia pugui estar trobant temperatures més agradables aquí, pugui estar reclutant més...
El paracentrótus està més afectat per l'aigua calenta?
El paracentrótus hi ha pocs estudis, però hi ha diversos que indiquen que sí, que les onades de calor o temperatures extremes podrien causar mortalitat. De fet, ara ens estan avisant de França, aquí també ho hem vist, a Barcelona, que hi ha zones segurament més, diguéssim, amb no gaire renovació d'aigua, però que s'ha vist molta mortalitat després de l'estiu. Aleshores podria estar associat a aquest augment de temperatures.
I una última cosa. Si volguéssim controlar la població aquesta dels eriçons, clar, hauríem de controlar, afavorir els peixos depredadors.
Idealment.
Què hauríem de fer?
Sí. Jo crec, la meva visió després de tots aquests anys és que estem en una situació intermitja. Intermitja en el sentit que la problemàtica que tenim ara és perquè no hi ha peixos. Però tenim l'oportunitat de fer una bona gestió de la pesca d'eriçons perquè és una activitat que existeix i que es demana, és a dir, hi ha interès comercial pels eriçons. Que a l'última hora hem de recuperar els peixos, si volem que de manera natural es controlin les poblacions d'eriçons. Jo penso que potser en el Mediterrani del passat, o sigui, en un Mediterrani en el que no hi havia gaire, o sigui, imaginant-nos, no? Això fa molts i molts anys, o sigui, és inimaginable el temps que fa, no? Però sense sobrepesca que hi ha, probablement l'activitat de pesca d'eriçons hauria de ser una activitat inexistent. És a dir, els eriçons, quan tenen el control de les poblacions de peixos, els trobes amb números molt baixos. No sé si una activitat extractiva d'aquest recurs seria viable. Aleshores, estem en un moment que hi ha interès per treure eriçons, tenim l'avantatge, l'inconvenient que hi ha molts, però l'avantatge que podem gestionar segurament la pesca perquè hi hagi menys i revertir la situació. Ara, fins que no recuperem els depredadors, no podem esperar. També una miqueta d'aquí surt la necessitat del projecte de deserts submarins, perquè hem basat sempre la història molt des del top-down control. Si falten peixos, aleshores els eriçons estan descontrolats i tenim deserts. Però hi ha casos bastant espectaculars. A Cabrera, que és un dels llocs més ben conservats, diríem, de la Mediterrània, hi ha deserts enormes provocats per grotes. A Medes també trobem pocs, però hi ha algunes zones amb deserts submarins. La història és bastant més complicada del clàssic top-down control. Aquí que Ballesteros estava a Laboratoire fa poc, amb National Geographic, i deia que s'havien trobat zones extensíssimes només d'eriçons i d'encants. Aleshores, sembla que la cosa és una miqueta més complicada. Evidentment, a part que hi hagi altres causes, com el canvi climàtic o l'augment de les temperatures, onades de calor, etc., que fan desaparèixer els boscos de macroalgues. O sigui, d'alguna manera el que pretenem amb Hidden Deserts és anem a veure quins són els diferents tipus de deserts que tenim, perquè clar, si hem de fer una restauració ens sigui el més cost efectiva possible i el més duradera possible, perquè segons a quines zones fem una restauració aquí al Mediterrani, probablement ens duri uns dies. Aleshores, perquè clar, si d'aquí 2 anys tornem a tenir garotes a punt de pala, doncs el bosc no perdurarà.
Bueno, primer de tot, enhorabona per al teu projecte i la presentació. La pregunta és una mica relació amb la Marta i en la teva opinió, perquè sé que això és molt difícil de veure, però quin creus que és l'impacte que més important, perquè l'estudi del mar és molt recent i llavors no pots comparar amb estudis de fa 500 anys o així, però quin creus que és el millor impacte? O sigui, impacte humà, impacte més de la carata, impacte més de...
Jo crec que actualment la majoria d'impactes són humans, no crec que hi hagi res que no estigui impactat per l'home. Aquí en el Mediterrani diria que la sobrepesca és el que més fa que veiem el que veiem al Mediterrani d'avui. Això sobretot relacionat amb l'estat de conservació de les macroalgues i a més després hi ha estudis del grup, per exemple, de l'efecte de la pol·lució que és clau en el que tu tinguis o no, però diguéssim el que a gran escala pot estar emmascarant el que nosaltres veiem avui del Mediterrani és la sobrepesca, penso, però evidentment el canvi climàtic i totes les seves, o el canvi global en general, totes les seves repercussions, doncs té una importància que moltes vegades passa més desapercebuda. Es parla molt dels plàstics, els plàstics està molt bé, és un impacte molt gran, però el canvi climàtic és una cosa que segurament passa més desapercebuda i quan t'ho trobes ja és massa tard. L'efecte de les onades de calor, per exemple, és bastant devastador. A Austràlia, em sembla que era el 2012 o així, va haver-hi una onada de calor que va acabar amb una extensió de boscos de kelps al voltant equiparable a 150.000 camps de futbol. Vull dir que la magnitud de l'efecte d'una onada de calor pot ser devastador. És difícil dir un impacte, però... Sí.
En aquest estiu al Mediterrani segurament també...
Sí, de fet ara ja, a part de les garotes que us comentava, esponges, gorgònies, gasteròpodes, s'ha vist en moltes espècies que hi ha mortalitats que podríem dir massives també.
Jo tinc una pregunta culinària.
Una pregunta culinària. Està bé.
No soc biòleg,
Està bé.
però la cuina m'agrada. Les lapes són immenjables?
Les lapes, jo les que he provat són boníssimes.
A la casa menjar crues, no?
Jo recordo el meu avi que les menjava directament crues. No, pregunto si es pot d'alguna manera incentivar la pesca.
Si no recordo malament, les lapes no es poden extreure.
No es poden extreure.
Aleshores, a Canàries, per exemple, se les mengen i és un menjar molt típic i molt preuat. Potser el tema de les lapes no diré que és anecdòtic, però sí que és un cas específic d'un feedback que funciona i que creiem que pot tenir repercussions molt importants, sobretot a les zones oligotròfiques. El que no he dit és que això només funciona a les zones oligotròfiques. Aquí, quan nosaltres traiem els eriçons, les lapes per si soles no són capaces de controlar el desert. Aleshores, quan es queden les lapes soles, el que va passant és que l'halo, aquesta marca de biorisme, cada cop es va fent més petit, el creixement de les algues supera el consum de les lapes i arriba un moment que les lapes moren. I aleshores tu veus que les lapes han segurament mort degut a que no poden ja menjar res perquè l'estructura de les algues que va creixent els ho impedeix perquè tenen una capacitat de moviment molt limitada. Aleshores, l'avantatge d'això és que segurament aquest feedback només existeix en zones amb molts baixos nutrients.
És que jo, per exemple, a vegades fent els snorkels sí que he vist a vegades molta amb roques així.
De fet, és això, quan hi ha roca descuidada també en espigons, que els eriçons es poden amagar millor de tempestes o de depredadors o així, que la roca és molt més pelada, aleshores allà surten moltes més lapes, ho veus més o són més grans. Hi ha aquesta facilitació de l'eriçó a la lapa i quan ja comença a haver-hi estructura de macroalgues, això diguéssim que no deixa de funcionar i la lapa no. I això passa també pels balanos, o sigui, hi ha una sèrie de feedbacks que actuen quan el desert s'ha creat. Hi ha els balanos cobreixen tot el que és la roca i no deixen pràcticament espai perquè recollir res. Quan tu treus els eriçons, el reclutament de les algues de sobre dels balanos és més fort que el que ells impedeixen per la filtració de la manera d'alimentar-se que tenen. Per tant, també hem vist que quan vam treure els eriçons d'aquestes zones, que estaven tots pelats completament i recoberts de balanos, els balanos va ser el primer que va morir, perquè qualsevol petita vegetació que creixia. Aleshores, això és una miqueta en aquest sentit de com múltiples impactes determinen canvis de fase tan grans en els ecosistemes que poden ser d'escales espacials i temporals molt bèsties i poden tenir repercussions molt grans en les característiques i els serveis dels ecosistemes.
Jo tenia una pregunta, però és molt concreta, perquè m'ha cridat l'atenció, ja ni me'n recordava, però ensenyava la Villefranche, els impactes que hi havia, que és la foto de la taula de taxifònia.
Sí.
Què havia?
Sí. Vaig al·lucinar. Això va ser una foto que vaig fer fa 3 setmanes, potser, i em vaig tirar a buscar eriçons, perquè la Jana m'havia dit que aquí hi ha eriçons, i vaig a buscar eriçons, i no hi havia eriçons, s'havien mort tots, no es representa per l'onada de calor, i aleshores vaig començar a buscar zones on em poguessin quedar, no sé què, i el que vaig veure és que jo en aquesta banda del Mediterrani no l'havia vist, a l'est del Mediterrani sí que l'havia vist en algun lloc, però aquí no, i estava superfrondosa, estava en molt bones condicions, sí. Recobria tota la mata morta de Posidònia que queda, doncs estava recoberta d'això, de petites taques de la caulepa.
Però ella sola, o hi havia altres coses?
Hi havia caulepa taxifòlia, hi havia la cilindraza també, apuntava per tot arreu. Sí, el que passa que la taxifòlia era molt cridanera perquè estava així gran, verda, molt... Sí, es veia excel·lent. I en alguns casos, com colonitzava els rizomes de la Posidònia per dins, no? O sigui, feia com des del marge de la mata morta fins a dintre de la planta.
Però de fet tu vas veure això en les mates de la Posidònia que estaven mortes, no? O sigui,
no, mates que estaven...
que estaven bé.
i creixia per allà. No arribava a colonitzar tot el que és l'interior de la mata, però sí que s'ajudava.
Va persistir, però d'una manera ja molt més.
Sí, clar, a mi de cop vaig pensar, quan la vaig veure, clar, és que el món acosta aquí al costat, no? Però bueno, no l'ha eliminat, està clar que no.
No, de fet ja havien dit que a Niça n'hi havia encara, el que passa que les poblacions són molt més petites, doncs va sortir així com acompanyant, però que tampoc no...
En aquesta zona estava, jo no l'havia vist mai també, diguéssim, tant, no sé, I després una cosa que m'he passat una miqueta per alt és aquest estudi de la Direcció General de Pesca per guiar una miqueta la gestió. Estem fent servir també imatges aèries agafades amb drons.
Ai, sí, jo havia dit als estudiants que parlaria de...
Sí, al final he posat tantes coses que ja no sabia, no? Ja havia demanat en algun moment, però aquí, si ho veieu, no? I si algú està interessat, doncs us puc explicar una miqueta més què és el que fem, exactament. Però bàsicament estem cartografiant zones de costa senceres. Per exemple, ara tenim tota la costa de Blanes cartografiada amb ortomosaics. I aleshores, dintre d'aquestes zones, els blancals és una de les coses que són molt evidents, perquè és roca pelada i contrasta molt de la senyal que et dona ja directament a nivell visual el que és una roca amb vegetació. Aleshores, el que fem és marcar aquestes àrees, fer una aproximació de l'extensió de blancalls que hi ha a cada tram de costa, i aleshores així podem, estem treballant en veure com això pot fer-se servir per guiar l'esforç de pesca. Sabem que hi ha unes parts de la costa, per exemple, el Cap de Creus, és un parc natural, hi ha una de blancalls, una de deserts, importantíssima. Doncs si podem concentrar l'esforç d'alguna manera en algunes zones de la costa que tenen més blancalls i són més vulnerables, doncs això ajudarà. I els drons són una manera molt fàcil de fer-te una idea d'això. Estem intentant fer coses més sofisticades amb el grup, més en base a buscar els patrons de fragmentació dels boscos d'algues, també fent servir els drons. El que fem és un tros de cada, diguéssim, el cartografiem, fent servir a vegades milers de fotografies aèries. Aleshores les ajuntem amb mosaics i estudiem les senyals RGB, que són els canals visibles, diguéssim, la senyal del visible, i amb l'estudi de la informació de cada una d'aquestes bandes podem saber si som capaços de distingir entre els diferents hàbitats. Per exemple, sobre la posidònia, que és una cosa molt fàcil, diguéssim, perquè la senyal és molt contrastada, o algues turf, o sigui, bosc d'algues turf o bosc d'algues blancall. Aleshores, això, les senyals que ens donen un dron molt simple, ara mateix ens permeten ja fer una classificació supervisada relativament bona de automàticament, fent servir tècniques de random forest, intel·ligència artificial, d'alguna manera, de manera automàtica dir aquí hi ha aquesta espècie o aquesta espècie, o aquest bosc, aquí hi ha bosc, aquí hi ha blancall, i separar entre els hàbitats. Aleshores, això és una cosa que comencem a tirar del fil i no he tingut temps d'explicar-ho perquè ja eren massa coses al final, però que també forma part del projecte, un projecte que tenim amb el grup i el projecte de postdoc a França.
Jo tinc una altra pregunta. De la posidònia, ara se'n parla molt també en termes de glucàrgon. Els boscos aquests que t'ensenyeu ara, també se'n podrien considerar glucàrgon o tenen un cicle de vida massa curt?
Mira, s'està fent tot el possible per dir que sí, no? No.
Home, que ho faci servir també com...
Sí. Està molt incipient tot això, hi ha molts estudis ara que estan sortint amb la productivitat i amb tot el cicle del carboni en relació a les... No soc el millor per explicar-ho, però crec que és molt depenent del lloc, molt depenent de l'espècie, molt depenent de molts factors. Pot ser-ho i hi ha autors que defensen que és molt important, sí. de la Posidònia és l'emblema també, no? Vull dir, clar, la Posidònia, què passa? Que a sota la part visible de la Posidònia tenim metres i metres i metres de matèria orgànica acumulada en forma d'arreles i rizomes que queden allà compactats, que això no s'erosiona. Per tant, això, si es manté allà compactant, doncs les algues, el funcionament és molt diferent. Doncs gràcies.